Hello guys, so today in this video we will be discussing the BFS algorithm. Okay, so what is BFS algorithm? BFS is called as breadth first search algorithm. It is a very popular algorithm which is used mainly on graphs. Why it is used on graphs, for what purpose? So if we want to travel a graph, we will be using this BFS algorithm. So I hope this thing is very much clear that BFS algorithm, we use this algorithm to travel through the graph given to us. Okay, the graph can be either given to us in the adjacency list format or in the matrix format. Okay, whatever it is, we can apply our BFS algorithm and get the job done basically. Okay, so let me clear up some terminologies first only. Okay, initial only. So in a graph, the node from which we will start traveling, or the node from which we will start our BFS algorithm, na, we always call that node as the source node. Okay, let's keep this thing very clear. Whatever graph is given to us, we will obviously start traveling that graph from one particular node. The node from which you start traveling or you start doing the BFS algorithm, we call that node as the source node. So I hope that thing is pretty clear to all of us. Okay, so uh, this thing is clear, and the source node thing is also clear. So now let's move to our BFS. Okay, so guys, let's imagine this graph is given to us. Okay, we have we have some node 1, then we have node 2, 3, 4, 5, then we have node 6, node 10, node 9. Node 1 is connected to node 5 with an edge. Node 1 is connected to node 3, node 4, node 2, and 3 and 4 are connected to 6. 6 is connected to 9, and 2 is connected to 10. So this thing is pretty much clear. So guys, we will try to apply the BFS algorithm on this graph. But one thing I want to make clear is we will start the algorithm from node number 1. So node number 1 is our source node in this problem. Okay, node number 1 is the source node. I want you guys to remember this very well. So guys, let me give a short intro of what happens in a BFS algorithm. In a BFS algorithm, na, we try to travel the things in a level wise order. Okay, in a level wise manner. So say this is the starting node, then these are the nodes connected to it. Okay, these are the nodes connected to it, and these are the nodes which are connected to these nodes. Okay, something like that. And then there are further nodes like this. Okay, let's just assume then there is one last further nodes. So in BFS, what will happen now? Let's say this is level 0. First we will travel the node with level 0. Always remember, in BFS, first we will travel the node which is having level 0. Then we will travel the node which is having level 1, which is having level 1. Okay, then we will travel the all the nodes which are having level 1. Okay, just assume it as some lift system or anything. Okay, anything which is level wise. So the first we travel the node which is at level 0, then we travel all the nodes which are at level 1. Obviously now we will be traveling all these nodes which are at level 2. Okay, which are at level 2. Then we will be traveling all the, or traversing all the nodes which are at level 3. Then we will be traveling all the nodes. Okay, there is only one node here which is at level 4. Okay, so guys, always remember this very simple thing, that in BFS we travel things in a level wise manner. Okay, in a level order way. Okay, first we go to the level 0, then we travel through all the nodes at level 1, then all the nodes at level 2, then all the nodes at level 3, then all the nodes at level 4. So I hope this thing is pretty much clear to all of you. Okay, now how do we perform this algorithm is very much important. Guys, in this algorithm we are going to use a queue data structure. Okay, so what does queue do? Either you guys can go search on Google, try to understand what queue is, but let me give a small intro of it. So queue is, just assume that we are having a container. Okay, container like this. Okay, from the right end, okay, from the right end we can do the input, we can add some numbers in this container, and from the right end we can remove some numbers. That's it. That's the only, like, just that's the main definition of queue. Just keep this thing in your hand, don't go much into the technical jargon for now. Okay, so in the queue, just assume that from one side you can put in some things, and from the other side you can remove some things. That's it, nothing more, nothing less. So how by just using a queue, how can we perform BFS, such a nice algorithm on a graph, just by using a queue? Sounds interesting, isn't it? So let's see how we can do that. So guys, this is our queue, okay? So see, this is our graph, okay? So first what we do now, the first step of the algorithm is that try to put this source node in your queue. So if I put this one in my queue will look like this. Okay, let me draw my queue now. My queue will look like this. Okay, this was my queue. It looks like this, right? Some pipe like this, and I have written one here. Okay, so guys, this is my queue. Now the second step of the algorithm is remove that one. Okay, we put that one from this side. Now the second step is to remove this one like this, and add all the nodes in the queue which are directly connected to one. That's it, that's the only algorithm. The algorithm is check the node which is inside the queue, remove that node, and add all the nodes which are directly connected to that node. So guys, the next step is what? I removed the one. Okay. Then in the next step, I add all the nodes which are directly connected to one and have been never been visited before. So guys, which are the nodes which are directly connected to one? So let us check. Okay. Let's go here. So guys, the nodes which are directly connected to one are 2, 4, 3, 5. So now it will look like 2, 4, 3, 5. Okay, 2 here. Then comes okay, not here. Here I just removed a one. Then I will write 2 here, 4 here, 3 here, 5 here. So guys, now the queue looks like this. I put 2, 4, 3, 5 in the queue. You can see that initially queue had 1, now it had what? It has what? 2, 4, 3, 5. Very good, very good. Now guys, in the next step, how does the queue looks? It looks like this. 2, 4, 3, 5. So guys, the algorithm is pretty simple. Now the next step is to observe this first element. Okay, so 2, 4, 3, 5. You just observe 2 and try to remove this 2 from the try to remove this 2 try to remove this 2 from the queue. Okay, so we remove this 2 from the queue. So now we have 4, 3, 5 in our queue. But what is the next step? The next step is to add all the elements which are directly connected to 2 and which have never been visited before. So if I check 2, 10 is the node which is directly connected to 2 and have never been visited before. I cannot add 1 because 1 we are already done with 1. We already traveled 1. Okay, so we'll not consider it again. So guys, the nodes which are connected to 2, they are 1 and 10, but we will ignore 1 and only focus on 10 because we are done with 1 already. Okay, it's basic common sense. Why will you consider the node which you have visited already one time? Okay, so the new node is what which is connected to it is 10. So I will insert 10. So now it should look like this: 4, 3, 5, and 10. Okay, now what do we do in our algorithm? It's pretty much clear. Always look at the first node and remove it. That's it. First remove this. After removing this, whichever nodes were connected to 4, just add them to the queue. So next step will be to remove this 4. I removed it. Okay, very good. I felt very happy, nice, chilling out. Very good. I removed this node. What a great achievement of mankind. But now, but now, but now, but now. So what will we do, students? So now, let's try to find the nodes which are directly connected to 4. We have to add those nodes at the back of the queue. So guys, the node which is connected to 4 is 1 and 6. But I will ignore 1. Why I will ignore 1? Because 1 already we have visited. So why to visit it again and again, right? Let's try to visit the node which is connected to 4 and has not been visited before. So 6 is the new node. So I add 6 at the back. Very good, very good. Now the queue looks like this. It is what 3, 5, 10, 6. Okay, 3, 5, 10, and 6. Okay, let me write it like this. So guys, the first step is pretty much clear. Always look at the first node and try to remove it. What you can see, 3. I just removed it. Okay, that's it. Nothing else you have to do. So I have a 5 here, I have a 10 here, I have a 6 here. Very good. But when you remove 3, you have to make sure that you add a node which was connected directly to 3 and has not been used before. So guys, to 3 I see 1 is connected and 6 is connected. 1 and I cannot use because we have already visited it before. But 6, the what is the issue with 6? Okay, I have to do the edge deletion. Yeah. But the see, 1 I cannot do because I have already visited. 6 also I cannot do. Why? Because 6 we just now put it in our queue now, so we have to ignore that. Okay. So this time we add no node to our queue. Now let's see what we have. We have guys 5, we have guys 10, we have 6. So first step is to remove this first node which you are looking at. So let's remove 5. What we have, 10 and 6. Next step is to add all the nodes at the back of the queue which were directly connected to 5 and have never been visited before. So guys, which are those nodes which are directly connected to 5 and have never been visited before? So there is no node, okay? Only one node is connected to 5, one which has been visited before. So we will be ignoring it, okay? So guys, now let's remove 10, okay? We have 6. But now guys, which are the nodes which are directly connected to 10 and have never been visited before? Only node connected directly to 10 is 2, but it has been visited before. So we will do nothing here, okay? So 10 is also removed. Now we have 6 guys. So next step is to remove 6. Okay, we removed 6. But now what is the next step? Next step is to add all the nodes in the queue which are directly connected to 6 and never have been visited before. So this 3 is directly connected to 6, 4 is directly connected to 6, and 9 is also directly connected to 6. But what? Guess what? We cannot use 3, we cannot use 4, okay? We can only use 9 because 9 is the new node, okay? Which is directly connected to 6 and have never been visited before. Sorry, I like just removed these edges. Let me add them again. Uh, get that there. So 9 is the only new node, okay? So I'm just adding it here, 9. So now it looks, no, now our queue looks like this, okay? Finally, nothing will happen. I'll just remove 9 and there is no node which is directly connected to 9 and have never been visited before. Only 6 is there, but the good thing with but 6 we have already visited. So why, it is common sense guys, why will we use the node which has already been used before, okay? So I hope that much is clear. So guys, this is basically the BFS algorithm. You know guys, what is the best thing of this algorithm? Because we are traveling things level wise, we will always get the short, we will be able to calculate the shortest distance of each node from the source node. That is the most important application. Let me write an application. Make sure you guys note down these things in your book as well or somewhere in your notes or Google Docs. We can always find the shortest distance to all other nodes from the given node. So we can find the shortest distance from node 1 to node 5, node 1 to node 3, node 1 to node 4, node 1 to node 2, node 1 to node 10, node 1 to node 6, and node 1 to node 9. Why? Because we were traveling things in the level wise format. Okay, what is the meaning of level wise? First, we travel the nodes or traverse the nodes which are at level 0, then level 1, then level 2, then level 3, then level 4. Okay, now. So, level is nothing but the distance of that node from the source node. So, level 0 is nothing but our source node itself. So, here the node 1 has level 0. Okay, let me write the levels here. So, guys, in our question, can you guys tell me which node has level 0? You can say level 0 or distance 0, whatever you want to prefer. Node 1 has level 0. Guys, which are the nodes which are at level 1? Not hard to find out. All nodes directly connected to 1, which are 5, 3, 4, 2. So, guys, the nodes at level 1 are 5, 3, 4, 2. Okay. Guys, the nodes at level 2. See, we are traveling things level wise. So, first 1 will be printed, then 5, 3, 4, 2 will be printed. Then is what? Level 2. Level 2 is what? 6 and 10 are at level 2. 6 and 10 are at level 2. So now then 6 and 10 will be printed. What is at level 3? The last node, which is the farthest away from node 1. That's why we are getting the shortest distance, okay? Because we are traveling things level wise. When you travel things level wise, obviously you will get the shortest distance from the source node, from the day or from the node where you started. The last node is level 9. So this is sorry, is node 9. So level 3 is of node 9. So guys, that this is the meaning of BFS algorithm. BFS algorithm means now, this means that all the nodes of level 0 will be printed first. Okay. Let me write BFS. all the nodes of level 0 will be printed first 1 will be printed, then 5342 will be printed, then 610 will be printed, and then 9 will be printed. Okay. Yeah, so guys, let's have a small look at the code as well. Okay, so always assume that BFS is nothing but, like, this is a very big jungle or a forest, and the fire has started from the source node and it is traveling like anything. First the fire is reaching level 1, then it is reaching level 2, then level 3, then slowly it burns the whole forest. Okay, that's the main essence of our BFS algorithm. Okay. Yeah, not used a very great color here. Yeah, so let's go to the code. So guys, in the code, first we accept int 10, which is nothing but the number of nodes. Okay, so in our case I have taken 10 number of nodes and 8 number of edges. Int m is nothing but the number of edges. We accept the number of edges, then I declare an adjacency list kind of thing. Okay, then I take input of nodes. So what is the meaning of x comma y? Okay, so x comma y means node 1 and node 2. Then I create a connection between node 1 and node 2. I write g of x dot pushback y. It means I am trying to create a edge from 1 to 2. Okay, g of x dot pushback y means I am trying to create this edge. Then I have written what? I have written g of y dot pushback x. This means I am creating a edge from y to x. Okay, so this makes sure that we have an undirected edge from x to y. So using this strategy, we will take all the nodes, all the edges, and make our graph. Okay. Once the graph is made, I've taken this same example. So source node is what? 1. So I write int source equal to 1. This used array is very much important. Initially I'm initializing all these used values with 0. Okay. Used of I. What is the meaning of used of I? Okay, let me write it. Let me write it here. Used of I is 0 if node I has never been visited before. Okay, else it is 1. Okay, if it has been visited. So guys, now the thing is that the source node is 1. Okay, we push that source node to the queue. Okay, so in the queue we push 1. This was our 1, and we push this queue to our this 1 to our queue. I can show we did that in this example also. We push this one node now 1 to our queue. Okay, so I hope it is very clear. After that we run this algorithm. Okay, now what we do, we remove this node and we add all the nodes which are directly connected to 1. Okay, so what I do is, while queue is not equal to empty, first the node which we have to remove is what? The leftmost node, which is nothing but what? Q dot front. So int removed is nothing but Q dot front. Then I just print the node which has been removed. So see, 1 is coming here in the output first. I told na what will come in the output first, guys. Initially level 0 1 will come, then 5342 will come, then 610 will come, then 9 will come. So you can see first 1 comes, then 2 3 4 5, then 10 6, then the last one 9. Okay, they are coming in ascending order because in the adjacency list we are following the ascending order. That's fine, nothing else. So 1 removed was what? 1. Okay, now we are printing that one node. Okay, now we are popping it out, q dot pop. Now what is our next task? Our next task is to add all the nodes which were directly connected to the one at the back of the queue. So guys, which are the nodes that are directly connected to one? It is 5 3 4 and 2. So next task is to add 5 3 4 and 2 at the back of the queue. See, we did it here also. We removed one, then we added what? 2 4 3 5. So how will you do that? See, till here in the code it is clear that we have removed one, q dot pop, line number 42. Now, how to add all the nodes which are connected to 1? For that, you can write for loop auto u, then g of removed, g of 1. So, we will be iterating through all the nodes which are directly connected to node 1. Then I will be just using one more extra if condition, that node should not have been visited before. So if used of connected node is equal to 0, it means it is connected to node number 1 and it has never been used before. So you should directly add it to the queue. That's why I've written here q dot push u. Q dot push u. So what would be this u? It would be q dot push 5, then it would be q dot push 3, then it would be what? Q dot push 4, then it would be what? Q dot push 2. So like this, if I push all these 4 nodes in my queue, I will have be having 5 3 4 2 or 2 3 4 5, whatever you want to say, whichever order you consider. And as soon as I push these nodes, now you know what is the smart and the brilliant thing to do? make sure you write used of u equal to 1. Set this flag to 1 because now these nodes have been visited. Okay, so having the current status of used is very much important. So we just keep doing this algorithm and our nodes will be printed. You can see that they have been printed here. But guys, one more thing here which we could do is we can get the shortest distance from source node, node 1 to all other nodes by finding the level of those nodes. So guys, let's create an extra array of level n plus phi equal to 0. Okay. Guys, what is the level of the source node? It is obviously 0. Initially the level is 0, right? And source is nothing but 1. So level of 1 is 0. That is pretty much clear. But now guys, we have to assign the level value to the connected node also. So what will be the level? You can pause the video and try to imagine and try to think what should be the answer of level of u. Level of u is nothing but level of whatever node was removed plus 1. It's as simple as that. The value of removed is what? 1. Level of 1 is what? 0. So 0 plus 1, 1. So basically, node 1 is given level 0, and then we increment 1 as we go down. So level node 5 has level 1, node 3 has level 1, node 4 has level 1, node 2 has level 1, and then node 6 and node 10 will have level 3, and 0 1. Okay, sorry, this node 10, 6 and 10 will have level 2, and this node 9 will have level 3. Okay, so let's print the level also. So we print the node, then we will print the level. So cout level of removed. Level of the node tells you the distance of that node from the source node. Always remember that thing. So by using breadth first search algorithm in an unweighted graph, in a graph where each edge has a same weight, or say weight 1, you can find the shortest distance from the source node by calculating the level of each node with respective to the source node. Okay, so let me write the level. So guys, now things are pretty much clear. I will add the link to the code, the example and everything in the description. So you guys don't need to worry. Okay. So guys, node number 1 has level 0, node 2, 3, 4, 5 has level 1, then node 10 and 6 have level 2, then node 9 has level 3. See guys, how interesting is this? All the nodes got printed level wise. First all nodes with level 0, then 1, then 2, then 3. This is the main essence and brilliancy of BFS algorithm, which I wanted to explain you guys. Using this simple algorithm, we can solve hardest of problems, be it in CP, be it in Olympiads, be it OA, etc. Anything. Okay, and this algorithm is very much enjoyable. You guys will realize it in the future videos. So guys, for now it's midnight for me, I guess, and I am stopping the recording. Hope you guys enjoyed this session and got lots of learning, which will help you further in your learning journey or career, whatever, etc. Thank you, guys.